Hey, welcome back to Classifying Cats and Dogs in PyTorch. I'm your old friend Sheldon, and in this episode, I'm gonna be teaching you guys how to preprocess the data that you download from the last episode. And the first thing, we should ask ourselves a question. What kind of data do the neural network need for training? You might want to say, are you freaking kidding me? Images! And that is really not what I meant. What I meant was, specifically, what do you want from me? Let me put it this way. This neural network is like a new creature and it's saying, I'm hungry. And you have no idea what to feed him, but you do know that it wants images. But if you really just feed the neural network with raw images, it's like someone came to your restaurant and he wanted a piece of steak, but what you really offered him is a cow. So to prevent someone who got a cow kicks your ass, we might better figure out what kind of thing he really wants. To do that, we might have to think about how the neural network works. Well, generally speaking, for convolutional neural network, usually takes a pair of data, which is raw image data, and also the label. And then the main process is like this. First, you have to feed the neural network with your raw data. And without any training, the neural network will generate random predictions like this. And these predictions are usually very bad. Anyways, our code will compare the predictions with our label to generate something called the loss. And with the loss, we can use backpropagation to update our network so as to teach it to make better predictions next time. So obviously, what we need to provide is the data and the label. And if you still remember something about computer vision, I bet you may know that image is just a huge matrix which contains a lot of pixels. Specifically, like this. You may notice that the smallest unit has 3 numbers in it, and each number represents RGB channel respectively. But since we are actually using PyTorch as our machine learning framework, we have to convert the matrix into a tensor, which is the data type in PyTorch. Like this. Okay, don't be disgusted by this massive matrix. I'll make it smaller. Okay, now it is represented by its size. So, the first number on the left side is its channels. Obviously, it has 3 channels, which is RGB channels. And the second number is its width, which is 200. And the height is also 200. And the last number is gonna be the label, which is 0, representing the cat. Okay, let's go on to the next problem. You may notice that these images are in different shape. And if you have a look at a cat on the right side, you may notice that it is in grayscale, which only contains 1 channel representing the brightness. But these are easy to solve. For the channel problem, what we have to do is to see if this image contains 3 channels. If so, we save it. If not, we drop it. Like that. And for the size problem, it might be a little bit more complicated because we have no idea of the location of the object that we want to detect in the image. So the cropped image must contain the whole original image. And then this problem is easy to solve now. We take a look whether the width of the image is greater than the height of the image. If so, we choose the width of the image to make a square crop of the original image. Like this. Because if you resize them directly, the image might be distorted. And now the images are unified and resized to this size. And the last problem is like this. Imagine that you have tens of thousands of images to train. If you take only 1 image to train at a time, it might take too long to finish even for 1 loop. But if you say you want to take all the images together and throw it into the neural network, your computer might be broken. I'm just kidding, but you are very likely to get an out-of-memory resources error. To tackle with this problem, PyTorch offers a class called data loader, and it works like this. It takes a specific amount of data and squeezes them into a matrix like that. And now the first number on the left side is gonna be the amount of images that were squeezed into the matrix just now. And I guess you're familiar with the res3 numbers. And on the right side is gonna be the labels of those images. Okay, that's everything. Let's go to the next exciting part, coding. Okay, if you didn't watch the first episode, you can click the top right link to watch it, because we do need the data that we download in the first episode. So now we create a new file in our previous project. And based on our photo structure, the best solution is to use the image folder class, which is provided in the torchvision.dataset. So now with the image folder, we can simply say dataset equals image folders and put our root of our dataset here. And what I want to do now is to show you what's inside this dataset. And I'm gonna print this dataset directly, and you can see that there are 2,000 and more images in our dataset. And the next thing is to have a look at what kind of images we have. You can see that it actually didn't import the image itself, but the path to our images. And the targets inside the dataset contains every label of those images. And of course, for the classes in the dataset, it only contains 0 and 1, representing cat and dog. And now we delete our code here. And the next step is to split up our dataset into test dataset and train dataset. This can be easily achieved by using the train set split function inside the sklearn library. And this function returns train data, test data, train labels, test labels, respectively. So now we can simply use the train test split function. And the first argument is gonna be the images that we want to feed in our network. And the third argument is gonna be the proportion of the test dataset. And the last argument is gonna be the random state, but it doesn't really matter, just set it to 0. So now we can implement X and Y. The X is gonna be the images, so I'm just gonna use the images in the dataset, and the second is gonna be the target. And let's print out our new dataset and have a look at them. And you can see that they are perfectly split up. And you may notice that the train data and the test data already contains the targets, so these two are actually what we really need. You may notice that what's inside the train data and the test data is not the image itself, but the path to the image. So we need something like an adapter that returns the image itself when we call them. And this can be easily implemented with the dataset. And we are gonna name a new class, and it's gonna be called image loader and inherit dataset. And we have to implement some functions in it. The first, of course, is the init function, and the second is gonna be the getItem function, and the third one is gonna be the length function. Okay, the first thing we need to do is to give it a dataset. So dataset, and we have to make it become a param in this class. Okay, we can just do it like this for now. Okay, so now the length function can be easily implemented by returning the length of the dataset. And now we implement the getItem function. So now let's test it first. Let's just return the specific image in the dataset. So I already mentioned before that in the trained data, it only provides the path to the image here. So we have to use something to open up this image and return the raw data of the real data of this image. So I'm going to use the image provided by the PIL package here. So okay, let's return it like this. And here we have to return the second param, which is the label of the first param, which is the image. So now we make a instance out of image loader with the train data. Okay, and we get the first data out here. Alright, so let's print it out first to see what's what. Oh god, I got an error. Okay, this can be easily solved. Alright, so I got two objects. The first is the PIL image, and the second is the label. So we simply gonna get the first one, get the image, and show. Probably it's not gonna work like this. So I'm gonna take the first one. Okay. Alright, this works like a charm. Okay, now what we have to do is do what we were talking before. The first is to check if one image has 3 channels RGB or just one channel, which is grayscale. Okay, so here is the solution. We define a list. So we are gonna loop through the dataset, and if one image contains 3 channels, we put it in our list. If not, we just ignore it. So now, because we're using PIL image, so we can check the channel with the getBand function to get bands. And when we get a band, we check if it is equals to RGB. And if so, we append it into our list. Okay, to show you what's really going on here, let's print out all the bands from all the images here. Okay, let's comment out these 2 lines. Alright. Okay, let's run the function like this. Okay. Alright, we didn't make it a instant, so It didn't run the program. It didn't run the code. Alright, I think it's gonna work now. Okay, let's pause the program. Okay, let's see. Oh, here's one which is not RGB. Here's the second one. So this is the kind of images that interrupt your programs, so you have to handle it carefully. Okay, so let's uncomment this line and delete this too. Alright, the next one is to deal with the size problem. So how are we gonna solve that? My solution is to resize the image like I said before when we open the image. So in this section, I'm not gonna explain a lot because I have already explained before. And here we use the getBox function to get the bounding box of the image. Okay, hopefully it's gonna work. Oops, we got another error. Okay, it is actually get bounding box. So, okay, now we got what we needed. So in this picture, I'm gonna use this one to resize. So now I'm gonna crop it with the factor, and we're gonna implement the factor now. Alright, so the factor equals the width if the width is greater than the height, and if not, just reverse it. Alright, so this is gonna work, but because we're using Python and that is really a stupid way to do it, the smart way is to make the code more elegant, like this. Alright, now let's check the code. It's really good habit to check the code for every step, because if you only check the code, run the code in the end, you will encounter so many bugs that you cannot fix. Okay, now hopefully it's gonna work. Alright, that is what we needed. Alright, this feels great. Okay, so what is the next thing to do? I'm a little bit cocky now. So the next thing is to convert our data type into the tensor. What we're gonna do is to import transform module from Torch Vision. Well, this part might be a little bit difficult to understand for beginners, but just try, okay? So the first thing we need to do is to resize those images. We have already cropped those images, but still they're in different sizes. So what we have to do now is to resize them to 200 by 200, and the second thing we need to do is to transform those images into the data type of tensor. So the last part is to normalize the images. This part requires you to have some knowledge of computer vision, so I'm not going to elaborate on that. However, there's a little trick here I should mention. You can write your list like this, but since we're using Python and you're making a list out of 3 same numbers, you can just take a list of one number and multiply by 3. This can really make your code more elegant. So now I copy and paste it to our code. Alright, so what we need to do now is to add a new argument called transform and pass it into the class. So to prevent some errors, we need to let it equals none as default. And now pass it into the class. And now we have to make some modification in the getItem function. Now we check if the transform param is not none. And if so, let's return the transformed image. Well, this step is quite easy. Just put the image into this transform param. You call this transform as a function and put it in. So now we need to check the code again and print it out. Hopefully it's gonna work. Okay, so there's something wrong. We need to revert these 2 lines. Alright, so let's see. Oops, still. Alright, we have to make some modification here. We cannot put 2 numbers in it. We have to put a tuple in it like this. Well, the 2 tensor. Oh, we have to call the 2 tensor as a function. So now we get what we needed. Alright. So what we need to do now is to check the size of the image to see if it fits what we need. Okay, we need to call the size as a function. So now you can see that it has 3 channels, 200 for both height and width. It's working perfectly. So what we need to do now is to use the data loader, as I mentioned before, to load the data. So as a standard building class in PyTorch, this step is quite easy. So the first one is to pass the image loader in. The second is to define the size of the batch. The third one is to see if you want to shuffle the data. So this is how you can use the data loader. You have to make it into a iterator. And then you can call it by using the next function like this. Alright, so let's print it out to see what it's like. Alright, so it works like a charm. But now if you print it out like this, it may be a little bit hard for you to understand what's going on. So let's print the size out only. So everything works fine. The first one is the batch, and the rest, I think you understand that. So this is gonna be the end of the second episode. I hope you learned something. And if so, please subscribe and thumbs up. Hopefully I can still see you in the third one. Bye!